So today we were talking about ratios and what proportional ratios are, and we looked a little bit at how you can solve an equation and create an equation with cross-multiplying to identify the value of a variable in a proportional equation. We can also use ratios and this idea of proportional and cross-multiplication to find out if ratios really truly are proportional. It's a question you'll get sometimes in math is, are these ratios proportional? Okay, so for example, if I had, let's use numbers here, if I had 2 over 4 and we said, is that equal to 4 over 8? Are these proportional ratios? And we would know they are because it's times 2 times 2. Okay, we could also simplify this and say this is equal to 1/2. If I divide them by 2, divide by 2, then I could divide these by 4, divide by 4, and I get 1/2. So I'm seeing that they are proportional. Okay, they are equivalent to each other. But there's a method we can use using cross multiplication to prove this as well. Okay, so if I had my two ratios, 2/4 equals to 4/8, and I wanted to check to see if they're proportional. Now we already know they are, but I could check using cross multiplication. I simply go across that equal sign, go across that equal sign. So that gives me 2 times 8 equals 4 times 4, or 16 equals 16. If your ratios at the beginning were proportional, you'd end up with a number equaling itself. Now let's say I wanted to check one that was not proportional. So if I had 1/3 equals 2/3. Now we know these are not proportional. These are not equivalent. But if we were to cross multiply, we would see that as well. 1 times 3 equals 3 times 2, or 3 equals 6. We know 3 does not equal 6. So I would say these are not proportional. So we can use this cross multiplication to check things. If it's easy to simplify, we might have a really quick time. But we can also use cross multiplication, especially if we're seeing things like decimals. Okay, so if we had something like 2.5 over 7.5, put equal sign equals 3 over 9, and you're asked, are these proportional? We might look at that and at first glance say, oh, that doesn't look like it's really proportional. But if we were to cross multiply, 2.5 times 9 equals 7.5 times 3. Okay, if I do the math with this, I'll do it over here on the side. 2.5 times 9. Remember, I don't have to line up decimals when I'm multiplying. 5, and I get 22. Decimal point comes over once, so I get this is equal to 22.5. And then if I was doing 7.5 times 3, so 15, I get 22.5. So I get 22.5 equals 22.5. Yes, these ones are proportional to each other. 2.5 over 7.5, or 2.5 to 7.5 is the same as 3 to 9. They are proportional ratios. A lot of times too, you'll be looking at like a problem, and they'll say, are these two scenarios proportional to each other? And the thing we want to remember when we're doing that is if there's units, we just line up our units in the same place. So if we had, for example, 5 pounds of dry ice takes 30 hours, okay, to sublimate, that's turning from a solid to a gas. And we were asking, okay, and how about if 4 pounds took 24 hours, are those proportional? So I would take the word problem, I would write out my proportions, or my ratios, keeping pounds on the top, and hours on the bottom, and hours on the bottom. If I've done that, then I can really easily just set it up. 5 over 30 equals 4 over 24. I can't easily multiply, or well, I could do some simplification. That's one way to do it. Or I could just cross multiply across. And that would give me 5 times 24 equals 30 times 4. 5 times 24 does in fact equal 120. 30 times 4 also equals 120. So I would say yes, these two ratios are proportional. Okay, so the rate at which this dry ice is sublimating is consistent. So checking to see if ratios are proportional, If we can simplify, that's one way. If we can turn the equation, the ratio into the other, that's another way. And finally, if we cross multiply and we get the same number, that is a third way.